Hello my dear students, good morning all of you. Welcome to Kreatryx channel, welcome to Unacademy and welcome to Impulse batch. Before going to start our discussion today, let me introduce myself. I'm KV Swami. I did my MTech in Systems and Signal Processing from JNT College of Engineering, Hyderabad and passed out in the year 2007. And since 2009, I was into this GATE coaching field, teaching the subjects signals and systems and communication throughout the country. I have 12 plus years of teaching experience and now I'm associated with Unacademy. And if you want to purchase any course on Unacademy, you can use my code KVS Live, with which you'll be getting flat 10% discount. Any course on Unacademy you can purchase using the code KVS Live. First of all, we'll observe what are the various courses for GATE we are having in Unacademy. Basically, we are having two types of subscriptions, namely the Plus subscription and the Iconic subscription. In the Plus subscription, the student is exposed to live classes, crash courses, weekly tests are conducted, doubt solving sessions are there, and batches are conducted in both English and Hindi. If a student is not comfortable with English, he can take the batch in Hindi, and if a student is not comfortable with Hindi, he can take the batch in English from his choice of educator. And we have rank improvement batches also. Apart from this, we have one more type of subscription known as Iconic subscription, in which a personal coach is allotted to the students, study planner is given, study booster sessions are there, personalized test analysis is taken, and preparatory study material is given, along with doubt clarifying instructors are also there. If you observe the fee structure in the Plus subscription and the Iconic subscription, GATE or ESE preparation in Plus subscription for 12 months, that is 1 year, it costs around 27,225 rupees only using the code KVS Live. GATE or ESE preparation in Plus subscription for 18 months, that is 1.5 years, it costs around 34,650 rupees only using the code KVS Live. GATE or ESE preparation in Plus subscription for 24 months, that is 2-year program, which is ideal for second year students, costs around 39,600 rupees only using the code KVS Live. Coming to the Iconic subscription, GATE or ESE preparation in Iconic subscription for 12 months, that is 1 year, it costs around 45,225 rupees only using the code KVS Live. In Iconic subscription, GATE or ESE preparation for 24 months, that is a 2-year program, it costs around 66,600 rupees only using the code KVS Live. Okay, so whatever may be your subscription, either Plus or Iconic, use the code KVS Live to get maximum discount. And one more point I want to tell you that today, that is on 4th April, tomorrow on 4th April, see, Unacademy is coming with an exam known as Unacademy Combat. It is a 60 minutes exam, that is 1 hour duration exam, and the branches eligible are ECE, Computer Science, EE, Civil Engineering and Mechanical. And if you are going to top in this Unacademy Combat, top 3 winners from each branch will get 100% subscription, 100% scholarship on Plus subscription, means they need not pay any amount for Plus subscription. So the top 3 winners from each branch will be having this facility, and 100 winners from each branch will get additional discounts. So I request all of you to propagate this information, right? And if you want to unlock this one, Unacademy Combat, you can use the code KVS Live. KVS Live. Save the date, April 4th, that is tomorrow, 11 AM. 11 AM. Right. Those who are coming for the first time, please subscribe the channel and share the session. And all of you give your attendance by pressing the like button. Good morning, Adarsh, Jaitirda, Vamsi, Manu. Okay. See, today's discussion is on, today's our topic is a mini marathon on the properties of systems. Basically, we are discussing the properties of systems, right? in our regular class. Now we'll do a small marathon based on the properties so that you'll get perfection on the topic. So the first question will be like this. All of you try to answer this one. Anyway, I'll be giving the solution also. Read the question carefully. Read the question carefully, all of you. A continuous time system with input x of t and output y of t is given by, this is the input output relationship he gave. Discuss the linearity, time invariance and stability. Now you can type your answer in the chat box. He's asking about linearity, time invariance and stability for this input output relationship. Come on, all of you, try to solve this problem and share your answer in the chat box. Linearity, time invariance and stability, he's asking. And I'm pretty much confident that after this session, you are able to answer any question from the properties of systems. That much confidence you'll get from this test. Vamsi Krishna, all the answers you must type in a single line. Right. Now how to solve this problem? And I told you that if you're given this kind of input output relationship, you can draw the input output relationship, right? So how we are going to draw? X of t, y of t, right? Now y of t is 10 if x of t greater than 2, okay, and 5x of t if x of t lies between -2 to 2, and it is -10 if x of t less than or equal to 2. So I can give like this, between -2 to 2 it is 5x of t, 5x of t, like this. So at 2 it will be having a value of 10 because 5x of t. After 2 what happened? Constant value. Here also the same. Yes, I got the input output relationship, right? So some of your typing answers, TIV Jaitirtha, linear, time variant, stable. Okay, Jaitirtha, you said something linear, time variant and stable. First of all, look here, this is the input output relationship. Now let's check linearity. While discussing linearity, what I said, for a linear system, the input output relationship must be like this. The input output relationship must be a straight line passing through the origin. Straight line passing through the origin. But if you observe, it is a straight line passing through the origin, but after 2 it is not linear, right? Now how to verify whether this is linear or non-linear? Means I can simply say that this is non-linear. This is not linear, this is non-linear, my dear students. Non-linear. Sir, how you are going to say that this is non-linear from the input output characteristics? Means look here, linearity means what? Good morning, Chinna. Linearity means what? Additivity and homogeneity must be satisfied, right? Additivity means what? If I apply x1 of t, I'll get y1 of t. If I apply x2 of t, I'll get y2 of t for a linear system, right? y2 of t. What happens if I apply x1 of t plus x2 of t? If our system is linear, we must get y1 of t plus y2 of t, right? Now if you observe from this input output relationship, what happens if your input is look here, x of t, y of t, I'll take here. What happens if your input is 3, output is 10? What happens if your input is 4, output is still 10. What happens if I add 3 and 4? 7. Yes or no? So if our system is linear, it must produce 20 as the output because additivity must be satisfied. But if you observe, the output of the system to the input 7 is also 10. So which is not equal to 10 plus 10, no? So additivity is failed. So this is non-linear. Non-linear. Remember, my dear students, non-linear. Non-linear. First of all, observe the output at 3, 10, output at 4, 10. So if you add 3 and 4, if the system is linear, these two must be added. But at 7 also it is 10. So additivity is failed. Non-linear. Okay. Now next, so linearity is completed. Time invariance. So shift in the input is equal to shift in the output. And the procedure what I gave you, follow that one. You will get this as time invariant only. Very simple. Time invariant, you can easily check. Time invariant. First delay the input, after that delay the output. Right? So input delay will be equal to output delay, in which you can in which situation you can say that this is time invariant. Stability, bounded input must produce bounded output. So here if you apply any bound from this input output relationship, by looking at that only you can say if input is bounded, output is always bounded, right? Stable. Stable. So your answer must be non-linear, time invariant and stable. Non-linear, time invariant and stable. Non-linear, time invariant and stable. Okay. Fine. Let's go to the next question. Fine. Observe here, all of you. He has given a different kind of question here. Consider discrete time system with input x of n and output y of n given by. This is the discrete time system. Here D denotes delay. D means delay. D means delay here. Discuss linearity, time invariance and stability. Try to solve this one, all of you. Try to solve this one. Our marathon questions will always be different from the normal questions. Chinna, when syllabus will be completed, sir? It will take some time, Chinna. Come on. Discuss linearity, time invariance and stability. Any answers? Any answers? First of all, whenever you are given this kind of block diagram, you must get the input output relationship from which we can discuss linearity, time invariance and stability. Now how to get that? Look here, y of n is there, it is passed through a delay, means what is that we are going to get here? Y of n minus 1. Now this y of n minus 1 is added to x of n to get y of n. So I can write y of n is equal to y of n minus 1 plus x of n. Right? Can I write like this? Observe here. Y of n minus 1 plus x of n is y of n. Yes, we can write like this. Or you can simplify this as y of n. Any answers? Y of n minus y of n minus 1 is x of n. Is x of n. Now, this is what is known as a difference equation. Difference equation. Discrete time systems are specified by discrete difference equations, whereas continuous time systems are specified by differential equations. This is somewhat similar to dy of t by dt, is kind of thing, right? Now we have seen that first difference here, y of n minus y of n minus 1 means we are taking the first difference. First difference is similar to differentiation in continuous, already we have seen. So this is difference equation. Now we have to judge for what properties is asking? Linearity, time invariance and stability, right? Linearity means what? If you are given a differential equation, so linearity, how you are going to verify? Hope all of you remember. The coefficients what you are having, they may be functions of the independent variable, but they should not be the functions of dependent variable. The same thing holds here. Observe the coefficients. If the coefficients are functions of independent variable, okay, but if they are functions of dependent variable, so non-linear. So here all the coefficients are constants only, so I can conclude that this is linear. I can conclude that this is linear, right? Okay. Now coming to the time invariance. Time invariance means, suppose if you are given a differential equation, how you are going to check for a time invariance? See, coefficients whatever you are having for a differential equation, they should not be the functions of independent variable or dependent variable. The same thing holds good here. The functions are not the coefficients are not functions of independent variable or dependent variable, because in the coefficients we are not having n or y of 2n. The coefficients are not in this form, so we can say that this is time invariant. Time invariant. And the third one is what? Is asking about stability, right? Stability, how you are going to verify? Listen carefully, all of you. Listen carefully. Stability means, what do you know about stability? What do you know about stability? Bounded input must produce bounded output, right? Stability means bounded input must produce bounded output. Now how you are going to verify? Linearity and time invariance, anyway you can verify, but look at the stability. Observe here, all of you. How you are going to verify for stability? This is important. Bounded input must produce bounded output. Apply bounded input to the system. So from yesterday's discussion, we know that x of n is equal to u of n. Discrete time unit step is a bounded signal. Bounded signal means what? Magnitude of that signal at any time instant, if you observe, it must be a finite value. So u of n, discrete time unit step, is a bounded signal. Apply and observe what happens. So y of n is equal to, listen carefully all of you, y of n minus 1 plus u of n. In the place of x of n, apply u of n. Now I applied the bounded input, but what is my output? I must observe the output, no? So you can solve this one in different ways. Observe here. Do one thing. Substitute n is equal to 0. Substitute in the place of output, substitute n is equal to 0. What happens? Y of 0 is equal to y of minus 1 plus u of 0, right? Y of minus 1. Do you have any previous outputs? No. So y of minus 1 is 0 plus u of 0. U of 0 is what? 1. Unit step signal at 0 is 1, no? So output is 1. Now what happens if I observe this output at n is equal to 1? Observe this output at different time instants. Y of 1. Now substitute. What happens if I substitute n is equal to 1? It is y of 0 plus u of 1. Y of 0 means what? It is coming from the previous output. Y of 0, 1 already we got. U of 1. U of 1 means u of 1, which is nothing but 2. Now observe here. What happens if I substitute n is equal to 2? This way of solving is what is known as recursion. So let me tell you one point, that this is called difference equation, recursive difference equation. Recursive. What it is known as? Recursive difference equation. Recursive means output depends on the previous output. Whenever your output depends on the previous outputs, it is known as recursive difference equation. Generally, if you are going for digital filter design, IIR filters, infinite impulse response, IIR filters, they are specified by this kind of recursive difference equations. Observe here. Now substitute the output at n is equal to 2. Y of 2 is equal to, what will happen? Y of 1. Simply substitute here. We are not doing any rocket science here. Very simple. U of 2. But what is y of n? 2 plus 1, 3. Observe at one more instant. N is equal to 3, you observe. What is y of 3? Y of 3 would be y of 2 plus u of 3, which is nothing but y of 2 value is 3, u of 3. Unit step signal at instant 3 is 1, no? 4. Now, this is the nature. Observe here. Now, if you observe here, one interesting thing is, for n is equal to 0, look here, for n is equal to 0, output is 1. For n is equal to 1, output is 2. For n is equal to 2, output is 3. For n is equal to 4, output will be, sorry, for n is equal to 3, output is 4. For n is equal to 4, output will be 5. In general, if I substitute n, what will come? N plus 1 will come. N plus 1 will come. Yes or no? So, I can write the output as, observe here, I can write the output as y of n. In general, y of n is what? N plus 1. Y of n is n plus 1. Now, n plus 1, but we are starting from what point? We are starting from 0, no? So, do one thing, attach u of n. Attach u of n. So, if input is x of n, that is a bounded signal. If input is x of n, that is bounded signal. Look here. What is the shape of input? This is the shape of input. This is the shape of input, right? Which is a bounded signal. What is the shape of output you are going to get? N plus 1 u of n. So, how I must draw this signal. How you are going to draw? First of all, define n plus 1. For n, u of n means n greater than or equal to 0 and 0 for n less than 0. So, if you try to draw this one, what happens if I substitute n is equal to 0? 1. If I substitute n is equal to 1, 2. If I substitute n is equal to 2, 3. If I substitute n is equal to 3, 4. Now you tell me, this is the output what I am going to get is bounded or unbounded? Tell me. The output what I am going to get, this is input is bounded signal. Input is bounded signal. The output what I am going to get is bounded or unbounded? Tell me. It is unbounded. If you observe, this is the shape is like ramp signal, no? Ramp signal is unbounded. So bounded input is producing unbounded output. So the system is stable or unstable? Unstable. Unstable. So suppose if some of you say that I know Z transform, sir, I'll get the output using Z transform also. Your wish, you can get the same answer using Z transform also. N plus 1 u of n, the same thing you can get using Z transform also. No issues. If anybody wants, I can explain that one also. So here, first of all, look here. Stability, I'm explaining one more time. First of all, we got the difference equation. Difference equation. So in this difference equation, stability says that if you apply bounded input, you must get bounded output. So I'm applying bounded input. For different time instance, I'm observing n is equal to 0. If I observe it n is equal to 0, I'm getting the output as 1. N is equal to 1, I observed. I'm getting the output as 2. N is equal to 2, I observed. I'm going to get this as 3. N is equal to 3, I observed. 4. And if I observe at instant n means what? N plus 1 will come. I'm starting from 0, no? So I'm attaching u of n. That's it. This is my output. Try to draw that one. That will be unbounded. Bounded input is producing unbounded output. System is unstable. Yes or no? And what I said? This kind of difference equations. What is the name? Anyway, in future we are going to get. recursive difference equations. What are those known as? Recursive difference equation. Recursive means output depends on the previous outputs. Remember, recursive means output depends on the previous outputs. See, observe here. Present output is depending on the previous outputs. Present output is depending on the previous output. Recursive. IIR filters for EC people. Infinite impulse response filter, IIR filters, are specified by recursive difference equation, and IIR filters are unstable. FIR filters are always stable, whereas IIR filters are unstable. How can you say? Observe here. So lot of analysis is there in this problem. Hope you understood this one. Yes or no? Shall we go to the next problem? Reply is required, my dear students. Make the session interactive. Make the session interactive. So you are not sharing PDF in Telegram. I'll share. Don't worry, Vamsi Krishna. Yes. Important problem. This one is important problem. Linearity, time invariance. Anyway, we can check. Linearity and time invariance we can check, but stability is important. So let's get back to the next question. Fine. A continuous time system with input x of t and output y of t is given by y of t is equal to rect of x of t, where rect denotes rectangular function. Rectangular function. Rect means rectangular function. Rectangular function. Discuss linearity, time invariance, causality and stability. Come on, type your answers. Type your answers. Type your answers. All of you must solve. After this session, you must be perfect with each and every property of the system. I'm not getting any answers, shall I? Linearity means try to draw the input output relationship. From that only you can get. Very simple. Manu has given non-linear, time invariant, non-causal and stable. Vamsi Krishna, non-linear, time invariant, causal and stable. Manu, please check your answer. How come it is non-causal? It is causal. See, first of all, do you know what is the rectity shape? Rectity. Rectity means this one, this shape, no? Rect of x of t means what? X of t. This is y of t, right? Now, linear, no, because linearity requires this kind of input-output relationship passing to the origin. Simple check. Linearity means what? Here you can check. Zero input, zero output property must be satisfied. For a linear system, zero input, zero output property must be satisfied. No, if input is zero, output must be zero. But if you observe, if input is zero, output we are going to get some value as 1. So this is non-linear. Non-linear. Okay. Time invariance. So if you observe rect of x of t, input delay, output delay you calculate. So input delay, rect of x of t minus t naught. Output delay, wherever you have t, replace it with t minus t naught. So both are same now, so it is time invariant. Causality. Causality means what? Output at any time instant must depend on present and past values of input, but not on future. Observe here. Y of t, x of t is there. So this is causal. Causal. Stability. Bounded input must produce bounded output. Yes. If input is, if you take any bounded input here, rect of that one will always lie between -1 to 1, some with a value. Right. So it is stable. Okay, stable. So it is non-linear, time invariant, causal and stable. Non-linear, time invariant, causal and stable. Bounded input will always produce bounded output here. Fine. Next question. Array, networks question. This is not networks question. This is our question only. Comment on the linearity and time invariance of the circuits shown. I've given you 3 circuits. You must comment on the linearity and time invariance. You must comment on the linearity and time invariance. How you are going to do this? Hint I am giving, write the KVL. KVL for each circuit you write, then you will get input output relationship from which you can say. Try to write the KVL for every circuit. For the first circuit, if I write the KVL, what will happen? See, 3i of t. For the first circuit I am writing 3i of t. Okay, and inductor is there. Inductor means voltage L di by dt. So 2 di of t by dt is equal to v of t. V of t. Right. Now, can I arrange this as di of t by dt plus 3 by 2 I of t is equal to, Manu has written some answers. Okay, we'll verify Manu. Di of t by dt plus 3 by 2 I of t is equal to 1 by 2 v of t. 1 by 2 v of t. Fine. Now, first circuit, I got the differential equation. Differential equation, linearity. How to check? How to check? See, if you observe, all are linear elements only here. If you observe, we are having all linear elements only, di of t by dt, and here your coefficients are constants. Your coefficients are constants allowed, and in linearity, if the coefficients are independent variable, also allowed, but the coefficient cannot be functions of dependent variable. They can be functions of independent variable, but they cannot be functions of dependent variable. So I can classify the first circuit as linear, and time invariance means what? Observe all the coefficients. If the coefficients are not functions of the independent variable or a dependent variable, time invariant. So LTI, first one is LTI. Hope all of you got the same. First one is LTI. So these kind of questions can also be given in the exam. Second one, write the KVL. What happens? 3i of t plus 2 di of t by dt plus 4 is equal to v of t, is equal to v of t. Or I can write this as di of t by dt, di of t by dt plus 3 by 2 I of t plus 2 is equal to 1 by 2 v of t. 1 by 2 v of t. Come on. Linearity. Linearity. How you are going to verify? Linear. Second one is linear or non-linear? Tell me. Second circuit. Second circuit is linear or non-linear? Tell me. Second circuit is linear or non-linear? Nanda Kumar. Acha. You're talking about linearity first. Second one is linear or non-linear? Tell me. Second circuit. Always remember, my dear students, if any constant term, exactly, if any constant term appears in the differential equation, constant term appears in the differential equation, it is non-linear. It is non-linear. So constant term is appearing, no, plus 2. So this is non-linear. Time invariance. Time invariance means what? Please observe the coefficients of every term. If the coefficients are functions of the independent variable or dependent variable, time variant. Now the coefficients are all constants here. So non-linear time invariant. Non-linear time invariant. Non-linear time invariant. Now for the third one, what could be the answer? Here I'll do one thing. I'll erase this part so that I can write the differential equation. Three I square of t, 3 I square of t, here the voltage is 3 I square of t plus 2 di of t by dt is equal to v of t, or di of t by dt plus 3 by 2 I square of t is equal to 1 by 2 v of t. Come on, tell me for this. The third circuit, di of t by dt plus 3 by 2 I square of t is equal to 1 by 2 v of t. Here if you observe, in the second term I of t is multiplied with I of t. The coefficient is function of what? Function of I of t, means this is non-linear. Non-linear. And if the coefficients are functions of this independent variable, it will become time variant also. Non-linear time variant. The third one is non-linear time variant. Yes, non-linear time variant. Okay. Hope this is clear for all of you. Non-linear time variant. So the first one is LTI, second one is non-linear time invariant, whereas the third one is non-linear time variant. Non-linear time variant. Fine. Next one. Discuss the stability of y of t is equal to e power x of t, and the second one is y of t is equal to e power minus mod of x of t. you have to discuss the stability of these two. You can call them as A and B. A and B. So stability means what? Bounded input must produce bounded output. So bounded input means what? Magnitude of input must be a finite value. So for the first one, here x of t is a, if I take the magnitude of this one, this is a finite value. So e power finite, we know that e power finite is always finite. In the place of input, you have to apply a bounded input. Bounded input means what? Magnitude of input must be a finite value. So e power finite is always finite. E power finite, if you are applying a bounded input, you are going to get bounded output only for the first system. So this is stable. The first one is stable, remember. Y of t is equal to e power x of t is stable. Now if you look at the second one, y of t is equal to e power minus mod of x of t. Here this is a peculiar example. Here what happens if input is bounded? Look here. What happens if input is bounded? Anyway, for this input output relationship, output will be bounded. What happens? Look here. What happens if input is not bounded? Look here. For the second one, what happens if input is not bounded? If input is not bounded means what? Input can take the value. Look here. Input is not bounded means what? Input can take the value infinite also. Input is not bounded means it can take the value infinite also. Infinite it can take, minus infinite also it can take. So if x of t is infinite, look here, if x of t is infinite or x of t is minus infinite, input is unbounded. But if due to the presence of this modulus, what we are going to get? We are going to get the output as 0 only, right? So I can write for the second system, look here, y of t is bounded, if x of t is bounded or x of t is unbounded. So for the second system, remember my dear students, so for bounded input, bounded output you are going to get. For unbounded input also, bounded output you are going to get. The answer for the second one is y of t is bounded if x of t is bounded, or if x of t is unbounded also, y of t is bounded. Y of t is bounded. If x of t is bounded, definitely output will be bounded. If x of t is unbounded means if input takes the value infinite or minus infinite, we are going to get the output as 0, right? So y of t is bounded if x of t is bounded or x of t is unbounded. That is the answer. That is the answer. So the first one is stable. Second one is stable. The correct answer you can write like this. This is stable if x of t is bounded or unbounded. Second one is stable if x of t is bounded or unbounded. Bounded means take a finite value. Unbounded means take infinite value, plus infinite or minus infinite. Right? Duration of the session, it takes half an hour more. Okay, this is a fifth question. All right. Now, sixth question. A discrete time system can be static or dynamic, linear or non-linear, time invariant or time variant, causal or non-causal, stable or unstable. Examine the following systems with respect to the above properties. Means A, B, C, D, E. I think F is also there. F. For all this, you must find out whether it is static or dynamic, linear or non-linear, time invariant or time variant, causal or non-causal, stable or unstable. Come on, start doing. First one is what? Y of n is equal to summation k varying from minus infinite to n plus 1 x of k. Summation k varying from minus infinite to n plus 1 x of k. Comment on linearity. Comment on linearity. Summation, no? Summation minus infinite to n plus 1, you have to take the summation. So okay, so summation means what will happen? It is linear. Now if you talk about the time invariance, time invariant or time variant, this one, time invariant or time variant. Time invariant or time variant. Input delay, output delay, you calculate. Time invariant, you will get time invariant. See, as long as this upper limit, in the upper limit we are having n, it will be time invariant only. Suppose in the place of n we have something like 2n or something, time variant it will become. Now causality, if you are talking about causality, here if you are going to calculate the output at 1, you are coming from minus infinite to 2 of the values of input. What is y of 1? Y of 1 is summation k varying from minus infinite to 2 x of k. You are calculating the output at 1, for which you are coming from minus infinite to 2 of the values of input. So it is non-causal, right? And static or dynamic? Static or dynamic? I am calculating the output at 1, for which I am coming from minus infinite to 2 of the values of input. It is depending on many values, so it is dynamic. Static means output at any time instant must depend only on the input at that instant only, otherwise dynamic. So next, stability is asking. Accumulation, no? Accumulation means the values will be added up. Always, yesterday in the class also we have discussed. See, this summation or accumulation is unstable, because if you are going to give u of n kind of thing, you will get ramp signal kind of thing. So unstable. Integrator is unstable in continuous case, whereas summation is unstable in discrete case. Remember like that. So it is linear, time invariant, non-causal, dynamic, unstable. Hope all of you got the same answer for the first one. Second one, y of n is equal to signum of x of n. Y of n is equal to signum of x of n. Come on. Y of n is signum of x of n is linear or non-linear? Signum of x of n is linear or non-linear? Suppose the same in continuous, signum of x of t. Signum of x of t, what is the shape? Continuous case, this kind of shape will come. Linear or non-linear? Non-linear. So here also non-linear. Okay. Time invariant or time variant? If you observe the input-output relationship, input delay will be equal to output delay time invariant. Causal or non-causal? N means causal. causal, right? And static or dynamic? Static. Stable or unstable? It is stable because bounded input will always produce bounded output. Whatever the input, the look here, its value always lies between -1 to +1 only. So it is stable. Right? So non-linear, time invariant, causal, static and stable. Hope all of you got the same answer. Let's try for the third one. What is the third one? Y of n is equal to x of n plus n into x of n plus 1. X of n plus n into x of n plus 1. Come on. Linear or non-linear? It is linear. Time invariant or time variant? Time invariant or time variant? Here n is there, no? N is there means time variant. Input because while delaying your output, wherever you have n, replace it with n minus n naught, no? So it will be time variant. Linear, time variant. Talking about causality. Suppose if I put 1 here, this becomes 2. So non-causal. Static or dynamic? Dynamic. Because of the second term. If second term is not there, the system would have become static. Stable or unstable? Here if you observe bounded input x of n plus n into x of n plus 1. If you apply a bounded input like u of n into u of n plus 1. Here if I apply u of n into u of n plus 1 will come. But n into u of n plus 1, if you are multiplying with the n, that won't be a bounded signal, but that will be unbounded signal. So this is unstable system. Remember, this is unstable. Not stable, it is unstable. Please verify. Unstable. So linear, time variant, non-causal, dynamic, unstable system. Okay. Now D. Y of n is equal to x of minus n plus 2. Y of n is equal to x of minus n plus 2. This will be linear. If you apply the procedure, linear. By looking at that only you can say linear. Time variant or time invariant? Come on, tell me. For this one, x of minus n plus 2, time variant or time invariant? Always remember, whenever reversal came is time variant only it is. Causal or non-causal? Non-causal. Reversal came, no? Non-causal. Static or dynamic? Dynamic. Stable or unstable? Bounded input. If input is bounded, its shifted and reversal versions will always be bounded only, right? Or if you want, you can take u of n and try to draw u of minus n plus 2. It will also be a bounded signal. So bounded input produces bounded output for this one. So this is stable. Hope everybody is getting. Please reply. Linear, time variant, non-causal, dynamic, stable system. Important examples: A, B, C, D, E. I told you, after this session, given any question you can answer. That is guaranteed from this session. Round of, look here, A, B, C, D. What? D I have taken this one. Okay, this is. Observe here. The next one is y of n is equal to round of x of n. Round of x of n. He's saying, what is round? Round of x of n denotes the integer part of x of n obtained by rounding. Integer part of x of n obtained by rounding. Y of n is equal to round of x of n. He has given the definition for round. Round means what is it? It denotes the integer part of x of n obtained by rounding. Obtained by rounding. Suppose if you have 2.5 means 2 integer part. Suppose 3.6 is there. 3 it is rounded off to. That is what he means to say. Now we have to check for linearity. Okay, round of x of n is linear or non-linear? Tell me. Round of x of n is linear or non-linear? Manu said non-linear. Okay. Observe here. I can say like this. Look here. Linearity means what? Additivity must be satisfied. Additivity means what? X1 of n plus x2 of n must produce y1 of n plus y2 of n. Suppose if I give 2.5. Round, it is rounded at to 2. Suppose if I give 2.6. It will be rounded to what? Again 2. Yes or no? Now, if I add these two must be added. Right? So what happens if I add these two? What is that I am going to get? 5.1. 5.1 will be rounded to 5. But this is not equal to 2 plus 2, no. So additivity is failed. Non-linear. Round of x of n is non-linear. My dear students. Jaitirtha, please observe. Arvind Reddy, it is non-linear, not linear. Additivity is failed. Look here. Rounding means what is it? Suppose if you have this kind of value, integer part. 2.5 means it is rounded off to 2. 2.6 means it is also rounded off to. But additivity means what? If the system is linear, if I add these two will be added. These two must be added. So I added x1 of n plus x2 of n is 5.1. But if you apply 5.1 to our system, it will give 5, which is not equal to 2 plus 2. So it is non-linear. Please verify. Please verify. Right. Now coming to time invariance. Time round of x. Jaitirtha, 2.6 would be rounded off to 3, right sir? But what he said, look at Jaitirtha. The rule what he said, round of x of n denotes the integer part of x of n obtained by rounding. Integer part of x of n means remove the decimal part, what he is saying. Okay. Now round of x of n is time variant or time invariant? Here round of time invariant. Input delay is equal to output delay. Causal or non-causal? X of n is there, no? Causal. Static or dynamic? Static. Stable or unstable? Here bounded input if you produce, always bounded output will get stable. Exactly, you are right, Arvind Reddy. So it is non-linear, time invariant, causal, static, stable system. Stable system. Okay. Now the last one, F1, F is here. So for that, let me erase this. Y of n is x of n if x of n greater than or equal to 0 and is 0 if x of n less than 0. Linear or non-linear? Come on, tell me, my dear students. Y of n is x of n greater than or equal to 0 and is 0 for x of n less than 0. Linear or non-linear? Come on, tell me. Linear or non-linear? Linear or non-linear? Nandakumar has said non-linear. Manoj also said, Vamsi Krishna has said. See, I'll do one thing. Take the continuous counterpart. Suppose if I ask you y of t is equal to x of t, if x of t less than, if x of t greater than 0 and is 0 if x of t less than 0. Suppose if I have this kind of situation. Now how you are going to plot x of t, y of t? When x of t greater than 0 only, y of t is x of t, right? But linearity requires this one also, this tail also it requires. Yes or no? So here tail is missing. So linear or non-linear? The same discrete counterpart also non-linear. Non-linear, you are right. Vamsi Krishna, please verify non-linear. Now the rest of the properties will be simple. Time invariant or time variant? Input delay, output delay you perform. Input delay, delay only the input. Here also it will be delayed. Output delay, wherever you haven't replaced with n minus n naught, right? So input delay will be equal to output delay, time invariant. Time invariant. And it is causal. Output at any time instant is depending on input at that instant only. Causal. And it is stable or unstable. Bounded input will produce bounded output only. So static, stable. In this way you are going to answer. Stable. Bounded input will produce bounded output. Y of n is equal to x of n. No. If x of n is bounded, output will be bounded. Right? Hope this is clear for all of you. How is this marathon session? Please reply in the live chat, my dear students. Hope everybody is enjoying. Reply. Let's go to the next question. Right. Next question. Consider the cascade of two systems S1 and S2. Right? Input to S1 is x of n, output of S1 is w of n, and output of S2 is y of n. And he has given some statements. First statement, if both S1 and S2 are linear, look here, if both S1 and S2 are linear, shift invariant, stable and causal, will the cascade also be linear shift invariant? Shift invariant means time invariant. Will the cascade also be linear shift invariant, stable and causal? That is the first question. Second, if both S1 and S2 are non-linear, will the cascade be non-linear? Okay, we'll verify. See, if both S1 and S2 are shift varying, will the cascade be shift varying? Try to solve this one, my dear students. Try to solve this one. One thing I can guarantee, that after this session, every question you can answer from systems. One property is anyway left, invertibility, that anyway we are going to discuss up to stability. So we got perfection in the first unit, the basics of signals and system, and after that systems. After that we can play with LTI systems. So he has given the cascade like this, no? First of all, cascade connection means what? If output of one system is connected as input to the other system, we say it as cascade connection. Right. Now, first question. Any answers? Any answers? Any answers? Nobody has given the answer. If both S1 and S2 are linear, shift invariant, stable and causal, will the cascade be the same? That is linear, shift invariant, stable and causal. What is asking? Suppose, look here, if this is linear, S1 is linear. If S1 is linear, so A into, look here, if S1 is linear, what is it? Both the systems are linear. If S1 is linear, A into x1 of n, look here, A into x1 of n plus B into x2 of n will produce what? will produce, if S1 is linear, AW of n plus BW2 of n. Yes or no? If for the first system is linear, okay, additivity and homogeneity must be satisfied, which can be given in a single expression. So A into x1 of n plus, yes Chinna, A into x1 of n plus B into x2 of n will produce A into W of n plus B into W, A into W of n plus B into W2 of n. If S2 is linear, look here, what he said, both are linear, he only said, right? Or I can write here, not, I can remove this if and I can put as S1 is linear, as S2 is also linear, A into W of n plus B into W, A into W1 of n plus B into W2 of n will produce what? A into Y1 of n plus B into Y2 of n. Now, if you observe the overall input output relationship, A into x1 of n plus B into x2 of n applied to a system is producing A into Y1 of n plus B into Y2 of n. Means if you cascade, overall cascade will be linear. Linear, first point is confirmed, linear. Linearity is confirmed, cascade is linear, because he said that both are linear. Both are linear means what? If the first system is linear, ax1 of n plus bx2 of n will produce ax1 of n plus bx2 of n will produce aw of n plus bw2 of n. As second system is also linear, aw of n plus bw2 of n will produce ay1 of n plus by2 of n. Overall system, if you consider, ax1 of n plus bx2 of n is producing ay1 of n plus by2 of n. Yes, this is what is required for linearity, right? Linear. Second one. Let's check the second one. Shift invariant. Okay, observe here. Both S1 and S2 are shift invariant or time invariant. Shift invariant or time invariant are same as S1 is shift invariant. Observe here. As S1 is shift invariant, x of n minus n naught input delay will be equal to output delay. For the first system, output is W of n. No? As S2 is also shift invariant, input delay, what is input to S2? W of n. So input delay W of n minus n naught will produce what? Y of n minus n naught. Now if you observe the overall input output relationship, x of n input delay is equal to output delay. Yes, shift invariant or time invariant. So the cascade connection is shift invariant or time invariant. Okay. Two properties are confirmed, that if both the systems are linear, the overall cascade will be linear. If both the systems S1 and S2 are time invariant, the cascade connection will be time invariant or shift invariant. Confirmed. Confirmed. So let's confirm the next two. What are those? This one is done. This one is done. Stable and causal. Okay, stable and causal. Right. Now, what he means to say is, if S1 and S2 are stable, will the overall cascade system will the overall cascade system is stable or not? What is asking, right? So let me take the other page. Look here, as S1 is stable, what will happen if S1 is stable? Bounded input will produce bounded output. So bounded input x of n will produce bounded output. bounded output W of n. See, as S1 is stable, he said that both the systems are stable, S1 and S2. So what I am saying is, if as S1 is stable, bounded input X of n will produce bounded output W of n. Means W of n is what? Bounded. Now this W of n is applied to what? S2. So as S2 is stable, this bounded input will produce bounded output. So we can write as S2 is stable, bounded input W of n will produce bounded output Y of n. So if you look at the overall system, look here, bounded input X of n is producing bounded output Y of n overall, if you observe. So the cascade is stable. So if two linear systems are connected in cascade, the overall system will be linear. If you observe, if two shift invariant systems are connected in cascade, yes, overall system is shift invariant or time invariant. If two stable systems are connected in cascade, the overall system is stable. So what is left over? Causality is left over. Causality. Right? Now causality means, what is the definition? You know, output at any time instant must depend on present and past, but not on future. Now for causality, what I am going to do is, look here, I am going to come from the reverse. Look here, because output we must observe now as, look here, for causality, I'll write here, for causality, what is going to happen? Output of S2 at n is equal to n naught will depend on what? Output. Look here, output at any time instant must depend on present and past, but not on future. Both the systems are causal. So output of S2 at n is equal to n naught will depend on the input Wn. Yes or no? Because for S2 input is Wn for n less than or equal to n naught. Can I say that output at any time instant must depend on present and past, but not on future, right? Now output of S1 at n less than or equal to n naught, because as S1 is also causal, will depend on the input X of n at n less than or equal to n naught. So if you observe the overall input output relationship, again it is causal. So the properties are preserved for cascade connection. Linearity, causality, stability and time invariance are preserved. Please observe. Clear? If you observe the overall input output relationship, output at any time instant is depending on the input at the present or past. So overall system is causal. Yes. Please verify. Now let's look at the second part. If both S1 and S2 are non-linear, will the cascade be non-linear? What is saying is, if both Manu, your answer is yes. If both S1 and S2 are non-linear, will the cascade be non-linear? Okay. Manu, we'll do one thing. In the B bit, what he said was, actually he has taken the systems like this, no? This is X of n, this is Y of n, this is S1, S2. Now what is means to say is, if S1 and S2 are non-linear, can you guarantee that output is also non-linear? No, I'll do one thing. Let's take two non-linear systems and connect them in cascade. Exponential, e power, non-linear, no? E power, and what I'll do here, natural logarithm I'll take here. Right? Now what is the output of the first system? See, I'm taking two nonlinear systems and connecting them in cascade. What happens to the overall system is asking. E power x of n. Ln of e power x of n is what? Ln of e power x of n is x of n. So overall output y of n is what? Overall output y of n is x of n. Now y of n is equal to x of n is linear or non-linear? It is linear. Now if you observe, two nonlinear system I took and I connected them in cascade, but I am going to get the overall system as linear. So we cannot say that if you are going to connect two nonlinear systems in cascade, the overall system is linear or non-linear. But it depends on the individual systems what we are going to consider. Or you can say that the overall system may be linear or may not be linear. Right? This is the answer for the second one. See, we cannot guarantee that if you are going to connect two nonlinear systems in cascade, the overall system is nonlinear. It may be nonlinear or it may not be nonlinear. Right? Understood? Or if you have any doubt, take two more nonlinear systems. Observe here. Square is nonlinear, cube is nonlinear, right? So apply x of n here, x square of n, x power 5 of n. So overall system y of n is x power 5 of n, which is nonlinear. Observe here, two nonlinear systems I connected in cascade. Here overall system is nonlinear. Here two nonlinear systems I connected in cascade. The overall system is linear. Means if you are going to connect two nonlinear system in cascade, you cannot say whether the overall system is linear or non-linear. It depends on the individual systems what we are going to consider. If you are going to consider the systems like this, the overall system will be linear, and if you are going to consider the systems like this, the overall system will be non-linear. So the answer is we cannot say. Right. So this is the third one. Let's observe. What is the third one? This one. If both S1 and S2 are shift invariant means time invariant, will the cascade be time varying? Any answer? Please think of. What is saying was, if both S1 and S2 are shift invariant, means the time invariant, will the cascade be time varying? If both S1 and S2 are time varying, will the cascade be time varying? I'll do one thing. Look here. Observe here. Observe here, all of you. Look here. Suppose if I ask you one thing. Y of n is equal to, all of you observe here. Y of n is equal to x of 2n. Time invariant or time variant? Tell me. Come on, tell me. Y of n is equal to x of 2n. Time invariant or time variant? Please reply. Y of n is equal to x of 2n is time invariant or time variant? I told you one basic principle also. Time scaling is time variant if the scaling factor not equal to 1. So it is time variant. Yes, it is time varying. This is also time varying. Time varying or shift varying are same, right? Now what happens if I connect them in cascade? What is it? If you are going to connect two shift invariant system in cascade, will the overall system be shift variant or not? Now what I'm going to do is, I'm going to connect this one, these two systems in cascade. Okay, all of you observe here. This is x of n, this is w of n, this is y of n. W of n is x of n by 2. Y of n is, listen carefully, w of 2n. This is time varying or shift varying. In the problem he said shift varying. Time varying or shift varying are same. Time variant, time variant. Now he's asking whether the overall system is time varying or time invariant. Observe here. I'll do one thing. Here in the input, Manoj, you have said something time variant. Let's observe, Manoj. Test always, we know the principle, right? If you don't know anything, test. 1, 2, 3 I'm giving here. 1, 2, 3 x of n. And do you know this operation? This is the interpolation, no? First one is interpolation, second one is decimation. Now x of n is 1, 2, 3 with arrow placed at 2. Now what is w of n? Interpolation means what? Increase in number of samples from the first unit, right? And if you are going for zero interpolation, so between the consecutive samples here, denominator is what? 2. Means how many zeros will come? 1 0 will come. So 1 0 2 0 3. This is my w of n. W of n. Now what is y of n? Y of n is w of 2n. W of 2n means decimation. How you are going to perform decimation? To the right and left side of this arrow, skip or discard alpha. See, alpha minus 1, the scaling factor minus 1 number of samples. Scaling factor is what? 2 here. So you have to skip one sample to the right and left side of arrow. Right side of arrow, see 2 will be as it is. Right side of arrow, skip one sample. Scaling factor minus 1 number of samples you must skip to the right and left side of arrow. So 0 you have to skip here. So after that 3 will come. Left side of arrow also 0 you have to skip, 1 will come. Now if you observe, y of n is same as x of n. Y of n is same as x of n. Now what I did, look here, I took two shift invariant or two time, I took two shift variant or time variant systems and I connected them in cascade, but the overall system is shift invariant or time invariant. So what is it? Observe the question now. If both S1 and S2 are shift varying, that is time varying, will the cascade be shift varying? No. No. Will the cascade be shift varying? No. It depends on the systems. We cannot say guarantee. We cannot guarantee. Right? But if you reverse the operations here, if you reverse the operation, see interpolation first of all I took, after that I took decimation. But if you take decimation first and interpolation next, you won't be getting the same output. So in that case, we will have a different analysis. Right, this is the answer. Both are shift varying. We cannot guarantee that. If both are shift varying, we cannot guarantee that the overall combination is shift varying. It can be shift invariant also, or time invariant also. Okay, this is about this question. All right, come on. Determine which of the following systems are stable. Simple question, simple question. A, B, C, D, E is given, sorry, A, B, C, D, which are stable. Come on, do it. Stability means bounded input must produce bounded output. Bounded input must produce bounded output. Come on, tell me. A, B, C, D. What are your answers? A, B, C are stable. Manu, observe here. X square of n. X square of n. See, bounded input if you take, if you square that one, definitely you are going to, definitely the resulting signal will be bounded only, or you test with u of n, right? So definitely bounded input will produce bounded output only. Y of n is equal to x square of n. This is stable, guaranteed. This is stable, because bounded signal multiplied with bounded signal will always be bounded. So the overall system is stable, right? Y of n is equal to e power x of n by x of n minus 1. Here, what happens if I apply x of n is equal to something like del of n? Del of n. Del of n is a bounded signal I can apply. See, discrete time unit impulse del of n is bounded signal, whereas continuous time unit impulse, that is del of t, is unbounded. Here one represents area, here one represents value. The value of continuous time impulse at t is equal to 0 is infinite, area is 1. So what happens if I apply a bounded signal like del of n e power del of n by del of n minus 1? What happens if n is equal to 1? What happens if n is equal to 1? Or what happens if not n is equal to 1, what happens if n is equal to 0? What happens if n is equal to 0? If n is equal to 0, what will happen? E power del of 0 by del of minus 1. E power del of 0 by del of minus 1 if n is equal to 0. Del of 0 is what? E power del of 0, 1. So E by del of minus 1. But del of minus 1 is 0, which is going to be infinite. True? So this is unstable. Second one is unstable. For many values of n, this will become infinite. Unstable. Cos of x of n, bounded signal. Cos x, if x of n is bounded, cos value always lies between minus 1 to plus 1. So bounded input will produce bounded output. So this is stable. This one, y of n is equal to summation k varying from minus infinite to n x of k. What happens if I substitute x of n is equal to u of n? Already we have seen this one. Y of n is equal to summation k varying from minus infinite to n. U of n is there, no? U of k. This is summation k varying from 0 to n. U of k by 1. This is n plus 1 into u of n. Already we have seen this one in our class also. N plus 1 u of n is ramp kind of signal. So this is unbounded signal. Unbounded signal. So this unstable. Unstable. System is unstable. Yes, Manu. Ninth one. Consider a discrete time system with input x of n and output y of n related by y of n is equal to summation k varying from n minus n naught to n plus n naught x of k, where n naught is a finite positive integer. Is the system linear? Is the system time invariant? If x of n is known to be bounded by a finite integer b, that is magnitude of x of n less than b for all n, it can be shown that y of n is bounded by a finite number c. We can conclude that the given system is stable. Express c in terms of b and n naught. Do one thing, you can take this as homework. Take this as homework problem. Very simple one only. Take this as homework. Answers I am giving here. This is linear. Linear will come. Yes, it is shift invariant, time invariant. Time invariant. You can verify c less than or equal to 2n naught plus 1 multiplied with b will come. Yes, 2n naught plus 1 into b will come. This must be your answers. Take it as homework. Homework problem. Okay. Now the last question. Only 10 questions we have taken because this is mini marathon now. Discuss linearity, time invariance, causality and stability for these four: A, B, C, D. Linearity, time invariance, causality and stability. Right? See, even part of x of n minus 1. Already we have seen even part or odd part of any signal is linear. Linear. Now, yes, Abhinav, I'm taking the class on our app also. So, even part already we have seen that it is linear. Now, coming to the time invariance, if you are going to take even part of any signal is defined as what? Signal plus its reversal by 2. So, reversal k means what? Time variant. Reversal k means time variant, because we know that Scaling, reversal is nothing but special scale of scaling. Scaling becomes time variant if the scaling factor not equal to 1. Reversal means scaling by -1. So it is time variant. So reversal came, no? In even part reversal will come. So it is time variant. Causality. Causality you can verify. Look here. Again reversal came. Reversal came means this will be non-causal. Non-causal. For example, if you observe y of t is equal to x of minus t is there. Continuous, if I consider y of t is equal to x of minus t. Y of -1 is what? X of 1. For -1 plus 1 is future value. So whenever reversal comes, non-causal. Stability. If you observe even part of x of n-1. So if the signal is bounded, if you calculate the even part of that, that will also be bounded. Take u of n as example. Take u of n and try to calculate the even part of u of n-1. That will also be a bounded signal. So stable. So linear, time variant, non-causal and stable is the answer for the first one. Linear, time variant, non-causal and stable is the answer for the first one. Okay. Second one. Abhinav Singh, are you taking class on app? I've done some videos on the app, Abhinav. You can verify. Soon I'm going to start communication also on the app. Okay. Y of n is equal to x of n for n greater than or equal to 1 and is 0 for n is equal to 0. X of n for n less than or equal to 1. Now discuss the causality, discuss the linearity, time invariance, causality and stability for the second one. B. Can I write this as, okay, can I write this input output relationship as y of n is equal to x of n, look here, x of n from what value to what value? N greater than or equal to 1 means u of n minus 1. Can I write like this? N greater than or equal to 1 means u of n minus 1 plus this is x of n again for n less than or equal to minus 1. N less than or equal to minus 1 means minus infinite to minus 1 means in discrete u of minus n minus 1. U of minus n minus 1. Right? It is you can draw the input output characteristics also if you wish. Right? What is it? Linear or non-linear? So it is linear. Pakka linear. Try to draw the input output relationship. Linear it will come. Or you apply the principle x1 of n you apply, x2 of n you apply, a into x1 of n plus b into x2 of n you apply. Linear. Try to draw the input output relationship. Right? What happens if you try to draw the input output relationship? Look here. X of n, y of n. N greater than or equal to 1 means from 1. So 1, 2, 3, minus 1, minus 2, minus 3. You have to do experiments. So if x of n is 1, y of n is 1. Because n greater than or equal to 1, x of n is y of n. This is 1. This is 2. 3. Right? 0 at n is equal to 0. 0 input, 0 output property satisfied. For minus 1, minus in, see, less than or equal to minus 1 means in terms of unit step, we'll write it as u of minus n minus 1. Okay. 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 This seems to be linear. Yes. This is linear. From the input output relationship also you can calculate or you follow the method. Next, time invariant or time variant. So here, first of all, delay only the input. Delay only the input. Observe here. Let me do it in the next slide. Y of n is what again? It is x of n for n greater than or equal to 1 and it is 0 at n is equal to 0, n less than or equal to -1, right? Input delay, delay only the input. Delay only the input. Output delay, and what I said, while delaying your output, wherever you have n, replace it with n minus n naught. Wherever you have n, replace with n minus n naught. Now this is input delay, this is output delay. They are not equal, so time variant. Time variant. Or you can apply in this one also, the expression what I have written. Time variant. Causality. Observe, if you observe, output at any time instant is depending on n greater than or equal to 1 or n less than or equal to 1. Output at any time instant is depending on the input at that instant only. So it is causal. Stability. Bounded input must produce bounded output. If input is bounded, output will be definitely bounded in this input output case. So it is stable. So linear, time variant, causal and stable. Abhinav, I didn't get your doubt on what topic means. Look here. C. Y of n is x of n for n greater than or equal to 1 and 0 at n is equal to 0, and x of n plus 1 for n less than or equal to -1. Discuss linearity, time invariance, causality and stability. What will happen? What will happen, my dear students? You can write in terms of unit steps also. This becomes x of n into u of n minus 1 plus x of n plus 1 into u of minus n minus 1. So this will be linear, you can verify, and this will be time variant, and this will be non-causal because y of n is x of n plus 1 for negative values. No, so it will be non-causal and it is stable. It is stable. Linear, time variant, non-causal and stable. Suppose if I apply y of -2, y of -2 means n less than or equal to -1, no? So it becomes x of -1. For -1 is future value. So non-causal and it is stable. If you take bounded input, definitely x of n and x of n plus, if x of n is bounded, x of n plus 1 will also be bounded. Bounded input will produce bounded output. So linear, time varying, non-causal and stable. And the last one, y of n is equal to x of n plus 1, linear, pakka linear. Time variant or time invariant? It is time variant. Y of n is equal to x of 4n plus 1. Input delay. Delay only the input. Or no need to solve this one also. What is asking? Time invariant, no? So scaling is there. So time scaling is time variant if the scaling factor not equal to 1. Not equal to 1. Here scaling factor is 4, no? So time variant. Non-causal. Non-causal. Y of n is x of 4n plus 1. No, if I substitute n is equal to 1, this becomes x of 5. For 1, 5 is future value. Non-causal. and it is stable. If you apply bounded input, so if you shift and scale a bounded signal, definitely that will also be a bounded signal, right? For example, you take u of n and observe whether u of 4n plus 1 is bounded or not. So it is stable. Linear time variant, non-causal and stable. So what I am doing is I am allocating 3 marks for each question. I am allocating 3 marks for each question, means what? 10 multiplied with 3 is 30 marks. Please tell me how many marks you got. Out of 30 marks, how many marks you got? 10 questions, each question carries 3 marks. How many marks you? Wouldn't be B and C be unstable as they are rising signal at higher values? Where? See, Jaitirtha, your answer, what you are saying, wouldn't be B and C be unstable as they are rising signals at their higher values? Its value is infinite, right, sir? See, forget about the output becoming infinite. See, for stability, what kind of input you will apply? Stability, you will apply bounded input. Bounded input only you will apply. For bounded input, y of n is equal to x of n will be bounded. Y of n is equal to x of n plus 1 will also be bounded. Okay. See, from this input output relationship, you cannot judge for stability. You apply any bounded signal, you take any bounded signal, shifted version of that bounded signal will be again bounded. That's what you must observe. Jaitirtha. Okay. Understood, Jaitirtha? So this is a small marathon session. Hope everybody liked this session. Please reply. How was the marathon? We are going to have this kind of marathon, many more marathons. This is just a sample. Please reply. How was the marathon session today, my dear students? This is the first question. This is the second question. Lot of things we learned from this marathon. This was the third question, fourth question. This is the fifth question. This is the sixth question, seventh, eighth, ninth, and 10th. Okay. And before leaving, follow me on Unacademy, unacademy.com at KVSwami. And these are our channels. This is our channel, Kreatryx channel. This is mechanical. Please inform your mechanical friends regarding this. Chemical and civil, computer science, Unacademy gate questions. This is also computer science, gate English, electrical junction, and apti express. Okay, so this is about today's session, my dear students. Thank you. And tomorrow, that is tomorrow at 7:30 a.m. I'm going to take a different topic, not the subject related topic, but I'm going to take a different topic, which is nothing but how to how to prepare for any competitive exam, right? How to prepare for any competitive exam. Some tips I'm going to give tomorrow, which will be very much helpful to you, right? So thank you. We'll meet tomorrow. And share the session, share the session, all of you. Hope everybody has given your attendance also. Sharing is caring, my dear students. You must share the session. Thank you. We'll meet tomorrow.